Hello, hello. Good greetings to everybody. Mr. Manyanya speaking. So, guys, today I'm going to talk about the intensity, that is the brightness of the light, when the frequency remains the same, and also frequency when it increases and the intensity remains the same. So, there are points here I want us to understand. Here, when the intensity of the light increases at the same frequency, we expect more photons. Sorry, my spelling. We expect more photons. Another thing that we must understand is that here we're going to have an increase in current. Let me just say current increases in the cell. Okay? But no change in maximum kinetic energy. So this is very important here, guys, that when the question asks you, normally it's going to be the last question where they ask you if the intensity of light increases and the frequency remains the same, what will happen? Maybe concerning about the maximum kinetic energy of the photoelectrons. So you can say that it remains the same. So the answer that you can say here, it will remain the same. You see? Because intensity just refers to the brightness. So what you expect there in the cell, you now have more photons. And the current in the cell, it will increase. Then there's no change in the what? In the maximum kinetic energy of the photoelectrons. But on this side, we're gonna have, let me say, greater kinetic energy of photons. So the energy increases, all right? But what we must understand, the work function remains the same. The work function remains the same. What we must understand also is that the maximum kinetic energy of the photoelectrons will increase. So here, when the frequency increases, but this one remains the same, the intensity remains the same, you must expect that the kinetic energy of the photons will increase, or it's going to be greater, but the work function will remain the same. Remember, every material has got its own work function, which is experimentally calculated to be, for that particular material, to be what it is. So it never changes, so it remains the same. But the maximum kinetic energy of the photoelectrons, if the frequency has been increased, it will increase. So that is all I wanted to explain, guys, theoretically, when it comes to intensity and the frequency. So let me try to apply that on this question. Exactly, I said when I was doing this question paper, I was going to explain this part. I hope this will be clear to all of you. If you look here at 10.4, the question reads, the intensity of the incident light is increased You see now, note what has been increased here is the intensity of the light without changing the frequency. In other words, the frequency remains the same. So, if you can allow me, guys, to just do this question here, let me do that. All I will do is just going to be 10.4. Remember, this is the continuation of the previous video on question 10 for a trial examination 2025. So, how will this affect the maximum kinetic energy of the emitted electrons? You see now, they tell you choose from increases, decreases, remains the same. Can you see that? So the question there, what happened? What change has been made? The change has been made to the intensity. So when it chooses here, they say now, what will happen to the maximum kinetic energy? That means the answer there, guys, is going to remain the same. Remains the same. That's the answer. The response, give the reason. When you're reasoning there, you can just say intensity does not affect maximum kinetic energy of photoelectrons. Or you can just say frequency remains the same. In other words, there is no change made in the frequency, it remains the same. So in other words, you can say intensity, sorry my spelling, intensity does not affect the maximum kinetic energy of photoelectrons. So between the two, this is your reasoning. So thank you guys for your time. I wanted to do this video for you all when it comes to this kind of question. So that's it for today. You know what to do. Hit the like button and follow me. Thank you. Meet you on the next episode. Thank you. Bye.